So, we have come to know what is food, then we have come to know, but this is the basic. Every time we will show you that course is dairy and food process and products technology, right. So, from there we have come to know the basic of food, the basic of nutrients, right. Now, we go that we have taken this fat, protein, carbohydrate, vitamins, minerals, water, right. Water is such that in your house you maybe say a fat, your sister, brother could be a protein, another mummy, daddy could be carbohydrate or some other thing. If they are considered like that, the basic requirements, basic necessity, right. But unless you have a house, they have no meaning. Similarly, it is that these nutrients, that fat, protein, carbohydrate, vitamin, minerals, unless water is also there, it has no completion of the cycle. So, water has to be given due respect, due position, and due appreciation for its purpose of taking it, right. So, when we have taken this fat, protein, carbohydrate, then we said that it helps you to maintain your body, it helps you to for your growth, it sustenance, everything. You see, when you were child, you were maybe 1 feet in height, 1 foot in height. Now you are 5 feet, 6 feet in height. So, you have grown up from that small to this big. How? And every stage this was helped by the food only. This was by the food only. There was no other thing by which it was, right. Now, you had played, you had done many things, you are doing this and that, I am talking, you are talking, you are watching. Where from the energy is coming? These energies are all supplied by the food. Then it comes the question, who is contributing how much, right? Fat is contributing. Now, of course, all engineering, all sciences are according to the units, are according to the SI unit, right. So, that SI unit is in energy terms in joules and others. But if we tell in that, then it may be some decimal numbers, say 5.2 or 8.9, like that. It is very difficult to remember. For that, even today, at least we do use though at MKS system till for this energy to be explained or said. Fat gives 1 gram of fat, it gives 9 kilocalories. 1 gram of fat gives 9 kilocalories, carbohydrate gives 4 kilocalories and protein gives also 4 kilocalories, right. So, carbohydrate and protein, they are 4 kilocalories per gram. If you consume per gram fat, you will get 9 kilocalories. So, it is more than double what you gain energy from fat than that of the carbohydrate or protein, right. So, that is why the food which is rich in carbohydrate or more parts in carbohydrate availability, that will give you one kind of energy, or the one which has high fat that will give you another kind of energy, or someone which is having high protein, that will give you another, right. Of course, in energy terms, we have just said that protein and carbohydrate do have the same number 4, but fat has 9 per gram, and the unit is kilocalorie. Keep in mind, normally we do the mistake that 1 gram and kilocalorie, right. So, of course, you can convert it into SI in joules or kilojoules as and when you need, but this 9 is easy to remember, 4 is easy to remember, right. So, if you convert them in SI, then it will be some decimal number which is not easy to remember, right. So, that is why still we call 944, 9 fat, 4 carbohydrate, 4 protein. So, let us look into different food items which gives what energy, right. Milk gives per 100 gram of milk gives 65 kilocalories, bread gives 230 kilocalories, butter gives 740 kilocalories, and egg gives 150 kilocalories. Now, from these numbers, is it not imaginable or is it not calculable that milk does not possess much fat, because it is giving only 65, right. So, fat, protein, carbohydrate, if we sum up together, then the energy total we get 944. So, 13 plus 4 17 kilocalorie per gram, right. So, from 100 gram we are getting 65 only. So, it is almost 3/4 we are getting from the milk that should contain like that fat, protein, carbohydrate in that range. Similarly, bread is giving around 230 per 100 gram, right. So, it should have sufficient quantity of fat, but it is not so. It is lot of carbohydrate, as we have seen in the previous class. We had shown you that what are the components which are available in bread as well as in milk. No. So, there we have seen that bread contains around 50% carbohydrates, right, and some quantity of little fat, little protein are also there. So, that is why around 230. Butter is basically fat, around 82 to 83% is fat, and some around 17% is 15 to 17% is moisture or water, and around 2 to 3% salt. Generally, you will see that butter, when you taste, it is salty. You do not have to add externally, normally some salt for the butter, but yes, if it is cream, there is no salt, right. So, butter contains salt, water as well as fat, around 80 to 83% fat. So, that is why it is giving such a huge energy, around 740 kilocalorie per 100 gram, right. Whereas, egg, it has, if you see the composition of egg in terms of fat, protein, carbohydrate, you will see they are not very high, right. Fat is also moderate, protein is also moderate, carbohydrate is low. So, in that case, it is somewhere in between, around 150, right. So, this tells that depending on your source of the food, depending on your intake of the food, depending on your type of the food, you are generating energy to the different levels, right. In the previous class, if you remember, I said balanced diet all the time, right. Again, this balanced diet is not part of the course, you will not see anywhere. But as I said during the very beginning, that it is not also possible to encompass a class within this kind of framework, because there are many associated things come in, where if it is then not told, then it becomes vacant, and that part should be known. That is why time and again, when this kind of situation will arise, we will try as much as information we can disseminate to you. So, that balanced diet will help you in what way? That this energy balance according to the requirement, because it is not only the energy which your body needs to build your body, as I gave the example that from the child or from the infant stage, when you were 1 feet height, now you have become 5-6 feet height, and such a huge growth from maybe 5-6 kg to now 60-70 kg. So, that huge growth, where from it came? From the food, and lot of it went into, yes, your daily activities, as well growth of your body, that weight, that building up of the body. So, protein and also your body structure like the bones and others. So, they need this, and all the food supply these need, right. And different food, as we have just seen, that they supply different kinds of energy, different terms of fat content, protein content, carbohydrate content. So, we must take some as the body is required, and there are other courses where these are more or less in detail studied or in detail told, which this is not possible for it, because there is you will see that that there are some common terms are also there, right. Common terms are also there by which the dietitians they do finalize, they do tell you that how much what you will consume, right. So, they will that is another ball game altogether, right. Now, objective, what should be your objective after studying? That you must make available nutritious food as cheap as possible. You must improve nutritive value and to minimize the loss during processing. Again, I give here one example that you have come across every day. Your mummy or seniors, when they are say processing means milk, okay, that is the most easy, or okay, rice or say wheat, right. When they are preparing, during the process of preparing, right from the raw material to the finished product, whether it is rice, whether it is chapati or whether it is milk, if you have, she has taken 100 grams or 1 liter of milk, or 100 grams of rice or 100 grams of wheat, the finished product he got never equivalent to 100, right. Some were lost. In the milk you will see some at the bottom of the container is associated, which you cannot take out. So, that is the loss, but this you cannot avoid. This you cannot avoid. What you can do? You can minimize. That is why when milk was being supplied to you, mummy had taken some spoon and scratched all these containers so that as much as comes out, right? So, you being the engineer or scientist, this will be your responsibility, that how minimum loss during processing you can attain, right? Then to ensure the storage ability at even normal temperature. I gave earlier also some example that milk you were keeping in the refrigerator, right? Now that is unavoidable, there is such a product. But again I tell you, milk, if it is pasteurized, then only it is kept in the refrigerator. But if it is sterilized, then it is not kept in the refrigerator. You go to the market, ask for sterilized milk, you will be given in some packaging material, and you will see that that was not kept in the refrigerator, that was in open atmosphere, though milk is so much susceptible, right. So, this is one example. So, it is coming to you that you must make that additional cost to be minimum, that you have to keep it at low temperature or some refrigeration or some other. So, that at room temperature if you can keep as much, that is your objective or your goal, it should be. Then to prevent food poisoning or contamination, in every other day you will see through news, through papers, that from this area or from that area, by taking this food, etc., etc., some or other kind of mishap had been happening or is still happening, right. Why? Because either the food was contaminated or the food was poisoned or spoiled, and after that it got poisoned, and because of that these mishaps did come up. So, your objective should be that you should minimize this poisoning or contamination as far as practicable, right. Then to cater special dietary requirements, somebody may need high carbohydrate and low protein, somebody may need high protein and low carbohydrate, minimum fat, right. So, depending on the requirement, your supply also has to be accordingly. So, you have to cater, you have to make food in that aspect, in that way, such that you can cater as the requirement is coming. Then to develop new varieties of instant and convenient foods. Nowadays, people are so much busy all over, people are so much busy that they do not get sufficient time to process or to cook or to make their food every day, prepare their food every day. So, if you can manage to supply that either pre-cooked or semi-cooked or almost cooked, half cooked, things like that, so that the consumer will have minimum time requirement for processing them, then your invention, your intervention into the system, everything will be fruitful. So, one of your goal also should be that you can make convenient food such that conveniently people can consume as and when they are requiring it, right. This could be your goal. Then we come for understanding some of the terminologies which are normally used. We call that this food has become perished or it is perishable. Right? What does it mean? It means that these deteriorates quickly after harvest, for example, fruits and vegetables, or soon after slaughter or catch, for example, fresh meat, poultry or fish. Right? So, those which are quickly deteriorated, they are called perishable. Right? And many of the foods come under this umbrella, that many foods are perishable or most of the foods are perishable. Perishability may be different depending on the food product itself, right, whether it is naturally available or whether it is being processed. Even then perishability also come in, right. So, those which deteriorate with time or early, they are called perishable, right. Then semi-perishable foods. The best example is egg, because you see again nature is our best friend. Nature is not the enemy, nature is our best friend. Nature has created such that egg, because from the egg, if it is hatched, then there will be the young, depending on what egg it is, right. So, if it is chicken egg, then it will be that the chicken will be hatched and it will produce some young. For that, nature has created one shell over that, because inside, if you see, in terms of fat, protein, carbohydrate and all others, everything is there, and this will be converted into a living thing, and an animal chicken will be produced. So, there it is nature given that the shell is provided such that these materials are protected. So, that is what we call semi-perishable, right. So, by definition we call it to be those contains natural inhibitors to spoilage, for example, egg and root vegetables. Egg and root vegetables, these are normally under the umbrella of semi-perishable, or have received some type of mild preservation treatment which creates greater tolerance to the environment conditions and abuse during handling and distribution, for example, pasteurized or smoking or pickling, all these, right. Normal, as we gave earlier example of normal milk, if it is in the hot summer kept, then it gets spoiled, right. But if the same milk is pasteurized, why do we pasteurize? We will come afterwards, but still, since it has come, why do we pasteurize? Pasteurize, this was termed at per the name of the inventor Louis Pasteur. So, he showed that if things are pasteurized, liquid foods are pasteurized, then the chance of getting ill or infected is minimum. So, what pasteurization is doing? It is killing all the pathogenic organisms. Pathogenic means those which are causing disease. So, disease producing organisms are getting killed by the process pasteurization, right. So, we can then keep it for some time, because the milk which you had originally heated, as I said earlier, you had boiled and maybe kept and consumed maybe after a couple of hours. So, by that time many organisms might grow into that, but they might not be pathogenic. So, in pasteurization, your fundamental thing is that you will kill all the pathogenic organisms which causes diseases, and you are not allowing any organisms to grow. Then after semi-perishable foods, let us define some more like shelf-stable foods, right. In many houses nowadays, of course, after so much urbanization, things have not become, you might not have come across so frequently, but at least during our childhood we had seen that many people used to buy lot of bora means container where rice is kept, right, that bag, Ghani bag, in that rice is kept for months together. So, people used to buy the entire lot, maybe because they are buying a lot at a time. So, some concession, some advantage might be obtaining. So, that is not nowadays, because our storage space is also not so much available as earlier, everything. So, what we are referring is that shelf stable food means which are by itself stable, right. Those are non-perishable at room temperature. For example, cereals, grains, nuts, or receive some kind of preservation treatment. For example, canning. You might have seen and taken some canned foods, right. And these canned foods are again boiled for a definite time temperature combination, so that organisms, whatever it be, is destroyed, and they are available for round the year. Storage period is very high. So, that is why they may be termed as shelf stable, right. Processed to reduce moisture content, for example, dried foods. Dried foods are also shelf stables, because one of the factor why organisms will grow is what is the moisture present in that, how much moisture is available for the organism to grow. If you are removing them by the process called drying, then you are bringing down the moisture content to the level where organisms cannot grow, and this is called your shelf stable. Then some other definitions like dry storage, that is storage at 20 degree centigrade or 50% RH, cold storage, that is storage below 12 degree centigrade, refrigerated storage, that is storage between 0 to 8 degree centigrade, then freezer storage, that is storage between 0 to minus 23 degrees centigrade. I am just coming. Shelf life, time duration between processing and consumption, light protected, that is the kept in dark or protected from visible light or wrapped with aluminum foil that prevents light reactions, right. So, under all these will come this today it may not be possible to go there, but will come next time. But till now whatever we have defined, under that you see refrigerated storage we have said 0 to minus 23, right. Since in this class time is almost over, but I will carry forward it to the next and bring this topic again, that Why we are saying it to be minus 23 or around that, minus 23, 25, 30, minus 18. This word minus 18, why it has come? You will see most of the books that frozen storage is at or below minus 18 degrees centigrade. In most of the books, any book you follow, you will come across this, that in most of the books it is said minus 18 or below. Why the number minus 18? Right? So, this we will discuss in the next class a little, because some story may be said so that you understand easily. Okay. Thank you.